Today we will see examples from exercise 3.2. This is our fourth lecture on this exercise. Integrate the following functions with respect to x. 3e raised to 2x plus 5 upon 4e raised to 2x minus 5. This we have to integrate. So let I is equal to the given integral. I is equal to integration of 3e raised to 2x plus 5 upon 4e raised to 2x minus 5 dx. So this example is in the form of ae raised to x plus b upon ce raised to x plus d. So here we will use the method that we will express the numerator using the denominator, as numerator is equal to a times denominator plus b times derivative of the denominator. So what is numerator? 3e raised to 2x plus 5 is equal to a times the denominator 4e raised to 2x minus 5 plus b times the derivative of the denominator, that is d by dx of 4e raised to 2x minus 5. Now what is the derivative of this? 4 into 2 is 8. So 8 e raised to 2x is the derivative. Now multiply this a by to this bracket, then collect the common terms, the coefficients of e raised to 2x and the constant term. Now by equality of the like terms, we will equate the coefficient of the like terms. So here e raised to 2x, here is also e raised to 2x. So 4a plus 8b is equal to 3, and this minus 5 is a constant term, and here is also a constant term. So minus 5a is equal to 5. So which implies a is equal to minus 1. So put a is equal to minus 1 in the first equation. You will get the value of b as 7 upon 8. Now we will put both the values in this formula. Numerator is equal to a times denominator plus b times d by dx of the denominator. Now we will replace the numerator in the given integral by this term. Then we will separate divide by that denominator to each of this term. You will get this. These two terms will cancel to each other, and here it is in the form of f dash of x upon f of x. So I can write it as minus 1 times integral of dx plus 7 upon 8 times integral of d by dx of 4 e raised to 2x minus 5 upon 4 e raised to 2x minus 5. So if it is in the form of f dash of x upon f of x, or you may use the substitution method. Put 4 e raised to 2x minus 5 is equal to t. So its derivative is present at the denominator. So that derivative and dx will be replaced by dt only, and you will get dt upon t. Its integral is log of t. But again, what is t? T is 4 e raised to x minus 5. So definitely we will reach to the step log of modulus of 4 e raised to 2x minus 5. So you can use by that method also, or you can use f dash of x upon f of x. It is equal to, its integral is log of f of x plus c. Now look at this example, cos raised to 8x into cot x. So what is this cot? Cot is cos upon sine, and this cos raised to 8, I can write it as cos square, it's raised to 4th power. Now cos square is 1 minus sine square. Okay, so now what we will do? We will use the substitution, put sin x is equal to t. So its derivative cos x dx is dt. So 1 minus t square, its 4th power upon t dt. Don't take the 4th power of this 1 minus t square, it's raised to 4. We get 1 minus 4 t square plus 4 6 t raised to 4 minus 4 t raised to 6 plus t raised to 8 upon t. Okay, so now we will divide each of these term by this denominator t. So 1 upon t minus 4t plus 6t cube minus 4t raised to 5 plus t raised to 7. Now in next step, we will integrate each of these terms separately. So the integral of 1 upon t is log t minus 4 as it is. Integration of t is t square upon 2, 6 as it is. Integration of t cube is t raised to 4 upon 4. Integration of t raised to 5 is t raised to 6 upon 6. And integration of t raised to 7 is t raised to 8 upon 8. So once you simplify, you will get I is equal to log of modulus t minus 2t square plus 3 by 2 t raised to 4 minus 2 by 3 t raised to 6 plus 1 by 8 t raised to 8 plus c. But again, the question arises, what is this t? Because we have given the example in the form of the variable x, and we have integrated it in the form of t. So again, we have to put what is the value of t. What is t? Then t is sin x. So the answer is I is equal to log of modulus of sin x minus 2 sin square x plus 3 by 2 sin raised to 4x minus 2 by 3 sin raised to 6x plus 1 by 8 sin raised to 8x plus c. So this is the integral of the given function. Now this tan raised to 5x, we have to integrate this function. So let I is equal to tan raised to 5x. So here I can write it as tan raised to 2 tan square x, it's a square, into tan x. So using laws of indices, I will get tan raised to 5x. Now what is tan square x? Tan square x is sec square x minus 1, bracket square upon this multiply divided by sec x. Why we have adjusted this sec x? Because I know that the derivative of sec x is sec x into tan x. So this term will be replaced by dt, and here you will get t square minus 1 bracket square upon t, like this. Okay, so take the square of the numerator, t raised to 4 minus 2t square minus 1 square is plus 1 upon t. Now divide the numerator each of this term by the t. You will get this term, integration of t cube minus 2 times integral of t plus 1 upon t dt. Now what is the integral? T raised to 3, its integral t cube is, its integral is t raised to 4 upon 4 minus 2 times integral of t is t square upon 2 plus 1 upon t integral is log of t, log of modulus of t plus c. I is equal to 1 upon 4 t raised to 4 minus t square plus log of modulus of t plus c. I is equal to 1 upon 4 sec raised to 4x minus sec square x plus log of modulus of sec x plus c. Now cos raised to 7x, I is equal to integral of cos raised to 7x dx. So I is equal to cos square x, it's a cube, into cos x dx. So I is equal to integral of 1 minus sin square x, it's a cube, into cos x dx. So here I will put the value of substitution, sin x is equal to t. So cos x dx is dt. So here this cos x dx will be replaced by dt, and here 1 minus sin x is replaced by t. So 1 minus t square, it's a cube. So a minus b bracket cube is a cube minus 3a square b plus 3a square ab square plus b cube. Using that formula, you will get 1 minus 3t square plus 3t raised to 4 minus t raised to 6 into dt. Take the separate integral of each of this term, and using the standard formula of integration, integrate with respect to t. We will get this for this integral. Now we will put the values of t, that is sin x. So t is sin x, I is equal to sin x minus sin cube of x plus 3 by 5 sin raised to 5x minus 1 by 7 sin raised to 7x plus c. Now the next example is tan 3x into tan 2x into tan x. We have to integrate this function, okay, with respect to x. So let I is equal to integral of tan 3x into tan 2x into tan x dx is our equation number 1. Now we have, I can write this 3x as 3x is equal to 2x plus x. Okay, now taking the tan on both the sides, so tan 3x is equal to tan of 2x plus x. Again, I know the formula, tan of a plus b is equal to tan a plus tan b upon 1 minus tan a into tan b. Use that formula. Take this denominator to that side, multiplied by tan 3x. You will get tan 3x minus tan 3x tan 2x into tan x. Take this term to this side and these two terms to another side. You will get tan 3x into tan 2x into tan x is equal to tan 3x minus tan 2x minus tan x. So our integral will be integral of tan 3x minus tan 2x minus tan x in dx. This is our new integral. So taking the integral of each of this term, you get log of sec 3x upon 3 minus log of sec 2x upon 2 minus log of sec x. This is the integration of the given function. Or I can write it as 1 upon 3 log of modulus of sec 3x minus 1 upon 2 log of modulus of sec 2x minus log of modulus of sec x plus c. Now sin raised to 5x into cos raised to 8x. We have to integrate these functions. Now sin raised to 5x into cos raised to 8x. So this sin raised to 5x can be written as sin square x, it's a square, into cos raised to 8x into sin x. Now this sin square x, I can write it as 1 minus cos square x, and I will put the value substitution cos x is equal to t. So minus sin x dx is dt, that is sin x dx is minus dt. So I is equal to integral of 1 minus t square, it's a square, into t raised to 8 minus of dt. Take the square of this first bracket and then multiplied each of this term by t raised to 8. So you get t raised integral of t raised to 8 plus 2 times integral of t raised to 10 plus minus integral of t raised to 12. So here you have to use integral of x raised to n dx is x raised to n plus 1 upon n plus 1. So minus t raised to 9 upon 9 plus 2 into t raised to 11 upon 11 minus t raised to 13 upon 13 plus c. I is equal to minus 1 upon 9 t raised to 9 plus 2 upon 11 t raised to 11 minus 1 upon 13 t raised to 13 plus c. Put the value of t, that is cos x. So I is equal to minus 1 upon 9 cos raised to 9x plus 2 upon 11 cos raised to 11x minus 1 upon 13 cos raised to 13x plus c is the integral of the given function. Now 3 raised to cos square x into sin 2x. So here I have to use the substitution cos square x is equal to t. So its differential is minus 2 cos x sin x dx is dt, that is sin 2x dx is minus dt. So here also it is present, so it will be replaced by only minus dt, and you will get 3 raised to t. So its integral is 3 raised to t log of 3 plus c. So integration of 3 raised to t is 3 raised to t upon log 3, and derivative of 3 raised to t is 3 raised to t into log of 3. So when I put the value of t, that is cos square x. So you get the answer minus 3 raised to cos square x upon log of 3 plus c. The 16th example is sin 6x upon sin 10x into sin 4x. So here this 6x can be written as 10x minus 4x. Now I will use the formula sin of a minus b, that is sin a cos b minus cos a sin b. Then I will divide each of this term by this sin 10x into cos sin 4x. So this sin 10x upon sin 10x will cancel to each other. Cos 4x upon sin 4x is cot 4x. Here also the sin 4x will be cancelled, and cos 10x upon sin 10x is cot 10x. Now what is the integral of cot theta? Cot ax is integral log of sin x upon a. So log of sin modulus of sin 4x upon 4 minus log of modulus of sin 10x upon 10. I can rewrite it as 1 upon 4 times log of modulus of sin 4x minus 1 upon 10 times log of modulus of sin 10x plus c. So integrate the following function with respect to x. Sin x into cos cube of x upon 1 plus cos square x. This is the integral which we have to, this is the function which we have to integrate. So cos square x, I am getting 1 cos x from this cos cube x. Cos square x into cos x, and that cos x along with this sin x. So sin x into cos x, and we will use the substitution of cos square x dx. Cos square x is equal to t, or 1 plus cos square x is equal to t. Both the substitution will work here. In one case we have to use the formula 1 upon 1 plus t, and in one case we have to use the formula 1 upon t. So cos square x is cos square x is t minus 1. So its integral is minus 2 cos x into sin x dx is dt. Okay, so, but it is sin 2x. but we need only sin x into cos x. So minus 2 will be divided to this side, minus dt upon 2. So our integral become integration of t minus 1 upon t into minus dt upon 2. This minus 1 upon 2 we can take outside the integral. Minus 1 upon 2 integration of t 1 minus 1 upon t into dt. So integration of 1 is t and integration of minus 1 upon t is log of modulus of t. So I is equal to 1 upon 2 times log of modulus of t minus t plus c. But what is t? T is 1 plus cos square x. So 1 upon 2 log of modulus of 1 plus cos square x minus 1 plus cos square x plus c. We can write it as I is equal to 1 upon 2 log of 1 modulus of 1 plus cos square x minus cos square x minus 1 plus c. This is the integral of the given function. So these are all about the exercise 3.2 based on the substitution method. Now we will stop here.